Hey guys, welcome back to my channel. So in this video, we are going to cover the next chapter of Head First Java. In this chapter, we are going to understand the concepts of objects and classes in Java. Okay, first of all, they have given one example here that will help you to understand the concepts of objects in a clear way. So once upon a time, in a software shop, two programmers were given the same specification and told to build it. The really annoying project manager forced the two coders to compete by promising that whoever delivers first gets one of those cool air-on chairs all the Silicon Valley guys have. Larry, the procedural programmer, and Brad, the OO guy, both knew this would be a piece of cake. Okay, so here two different programmers, Larry and Brad. Larry, who was the procedural programmer, it means he was going to write the code in any procedural programming language. Uh, Guys, I hope you know that what is a procedural programming language. If not, let me tell you, procedural programming language is basically a programming language where we write our software in the form of functions like the C. Okay, so we know that we do not have much scope of reusability in procedural programming language. So here Larry was going to take the approach of procedural programming language, and Brad, the O guy, was going to take the approach of object-oriented programming such as Java. Okay, so both of them start looking the specification given to them. So what is the specification in this case, in this example? There will be shapes on GUI, a square, a circle, and a triangle. When the user clicks on the shape will rotate clockwise. That is all the way to all the way around, and play an AIF sound file specific to that particular shape. Okay, so there is an interface. On that interface, there are some shapes drawn, and when the user click on particular shape, it should be rotated in a clockwise direction to 360 degrees. This is the specification of the software which they are supposed to develop. Okay, so they both started thinking that how should they start and what approach should they take to build this particular software. So the Larry, who is the procedural programmer, what he started thinking about writing the functions like rotate and play sound, and inside these functions only he's going to do all the programming that what will be the shape and what sound should play inside these functions only. But the Brad, who was the object oriented guy, he started writing the classes for each shape separately. So he created a class square, circle, and triangle. And then inside these classes, uh, he's writing the methods like rotate and play sound. Okay, so let's see. So but wait, there has been a specification change. Now what happens, as they have already decided the approach they will be taking to build this software, and they have almost written their code, the manager asked them that there is a specification change. And what is that change? That they have to add one more shape, that is amoeba shape on the screen with the others. When the user clicks on the amoeba, it will rotate like others and play a if sound. So now they both the programmers, they were asked to make some changes in the existing software they have developed. Now, what will Larry do? Because Larry has written this software in the mm, form of so many methods. Sorry, in procedural language, we don't call methods, but they are called functions. So he has written some functions like play, sound, and rotate. So what he has to do, he has to go inside these functions and make the changes accordingly. Okay, like he has to give these conditions that if the shape is not amoeba, then XYZ condition should be executed. But if the shape is amoeba, then XYZ condition should be executed. Okay. Now Brad, let's see, Brad, as he was an object oriented guy, what did he do? So he just has to make another class specific to the new change that has to be added. So he created another class amoeba and written its methods rotate and play sound. See, here is the twist. This is the key advantage of an object-oriented programming language, that you don't have to go inside the functions and make changes that make your software very, very complex, but you can simply use the concepts already existing in the object-oriented programming language that make it very, very easy to maintain. Okay, like in this case we have seen, just Brad did not have to do changes in the existing code, but he has created another class amoeba and started writing his function, his methods. Okay, let's see further. Larry snuck in just moments ahead of Brad. Ha, so much for that foofy OO nonsense, object-oriented nonsense. But this make on Larry's face melted when the really annoying project manager said, with that tone of disappointment, "Oh no, that's not how the amoeba is supposed to rotate." Okay, again the twist. When Larry has already made his changes in his functions, now the project manager is telling him that the way he has written his function in order to make the amoeba rotate is not the correct, because here his specification is something like this. See, the code written by Larry and Brad's version, it was something like this. The center is here and it should be rotated around this point. But the project manager wants that the center should be here and the shape should rotate like this. Okay, it should rotate, amoeba should rotate around this center. Okay, so again, let's see what changes they have to make. Again, we are seeing that in Larry's cube, he's again putting some conditions like, if the shape is not amoeba, then calculate the center point, then based on the rectangle, then rotate. Okay. Else use the X point and Y point as a rotation point offset and then rotate. But what did Brad do? He just introduced some new data variables in amoeba class that will calculate the center point, that is int x and int y point, and then he has written his rotate code and play sound code. Again, Brad did not have to make some complex changes, but in the class itself he just adds some data variables which are able to calculate the center point. Okay, let's move ahead. Now, not so fast, Larry found a flaw in Brad's approach. And since he was sure that if he got the chair, he'd also get Lucy in accounting, he had to turn this thing around. Larry, you have got duplicated code. The rotate procedure is an all four shapes thing. Brad, it's a method, not a procedure, and they are class, not things. Okay, so here we have to give some emphasis on terminologies. So in procedural programming language, the functions that we write are procedures, and in Java, in object-oriented programming language, the functions are called method. And the blueprint which is created by Brad, it's called class. We will see further in more detail when we will discuss the definition of class. Okay. So Larry mentioned that the code written by Brad, it has so much duplicate code. The function rotate, he has to write different function for each class based on the shape. So there is too much duplicacy. So Brad replied, first of all, the functions he has written, they are methods, and um he has written his methods inside the function. Then Larry, whatever, it's a stupid design. You have to maintain 4 different rotate methods. How can that ever be good? So Larry's question was very valid. Brad, oh, I guess you didn't see the final design. Let me show you how OO inheritance works. Larry, okay, so here comes the picture, real picture. So now inheritance is one of the concept of object-oriented programming language. Okay, so in inheritance allows the classes to inherit properties of one another. So here, see. First of all, I looked at what all 4 classes have in common. See, square, circle, triangle, amoeba. Both of these classes have these 2 methods which are common, rotate and play sound. Okay. So these all different shapes are shapes. So they all rotate and play sound. So I abstracted out the common features and put them into a new class called shape. So what did Brad do? He created a single class named as shape and put these two methods inside this class. Now he will apply inheritance here. He will create these four classes and make these classes inherit their superclass, this shape. So square here square inherits from shape. Circle inherits from shape. Triangle inherits from shape. Amoeba inherits from shape. So in this concept, the child class is known as, the class which inherits is called child class, and the class from which it is inheriting is called the parent class. So in this case, shape is the parent class and square, circle, triangle and amoeba are the child class. Okay. This parent class is also known as superclass. So what is Brad saying now? Then I link the other four shapes classes to new shape class in a relationship called inheritance. So this is the here comes the uh, concept of inheritance. In this case, what will happen is these four classes can simply inherit the methods of their parents class. It means these four shapes can inherit the rotate and play sound method. So let's see what they have written here. You can read this as square inherits from shape, circle inherits from shape, and so on. I removed rotate and play sound from the other shape. So now there is only one copy to maintain, which is in the parent class. The shape class is called the superclass of all other four classes. The other four are the subclasses of the shape. So we are seeing that these classes, child classes, are also known as subclasses. The subclasses inherit the methods of the superclass. In other words, if the shape class has the functionality, then the subclasses automatically get the same functionality. So if rotate and play sound is in the shape class, then we simply consider that square class also has these two functions. Sorry, these two methods. Okay. Now Larry has one more question, that wasn't that the whole problem here, that the amoeba shape had a completely different rotate method and play sound procedure. Brad method. Okay, they keep fighting about these terminologies, guys. So we have to remember that in Java we are using method. Larry, whatever, how can amoeba do something different if it inherits its functionality from the shape class? See, in this example, okay, let's see here we have this example. See, if amoeba will also inherit its rotate method, then we have seen that when the project manager changed the specification, amoeba's rotate and play sound method was very different. So now Larry is asking how can we implement that, because amoeba is not sharing the same rotate and play sound method like these three classes are doing, right? So Brad answered, that's the last step. Amoeba class overrides the methods of the shape class. Then at runtime, the JVM knows exactly which rotate method to run when someone tells the amoeba to rotate. So here comes the concept of the overriding methods. What happens is amoeba class can simply redefine the implementation of this rotate and play sound methods. So it means amoeba class can override these method and provide its own implementation at runtime. So Brad said, I made the amoeba class override the rotate and play sound methods of the superclass shape. Overriding just means that a subclass redefines one of its inherited methods. So what happens is here the implementation of rotate is different, and here the implementation of rotate is different. Amoeba class will have its own implementation defined here. So what will happen, what we can do is at runtime, we can simply call the rotate method of amoeba when it's needed. Okay. So overriding just means that a subclass redefines one of its inherited methods when it needs to change or extend the behavior of that method. So these are two overriding methods. Okay. So the problem solved. Now Larry still have one question. How do you tell an amoeba to do something? Don't you have to call the method and then tell it which thing to rotate? Okay, then Larry is asking that how will you tell an amoeba to do something?
So Brad replied, that's the really cool thing about OO. When it's time for, say, the triangle to rotate, the program code invokes the rotate method on the triangle object. The rest of the program really doesn't know or care how the triangle does it. And when you need to add something new to the program, you just write a new class for the new object type. So the new object will have their own behavior. So this is the really cool thing about object-oriented programming language. Like the individual classes have their own methods and instance variables. So whenever we need to introduce something new, we can simply make the changes inside that particular class only, or we can create a new class according to the new functionality introduced to the program. So here, like the triangle object has its own functionality and behavior, and the amoeba object has its own functionality and behavior. We can simply manage on runtime which object to call, and accordingly uh, the methods of that particular object the method of that particular class will be called easily. So this is how the object oriented programming language makes it easy to maintain the programming. Okay, so we don't have to make changes in such a way that it makes the software very complex. So here they have given some facts about object-oriented programming language. So we are not going to read it. Let's move ahead. Okay, now here they have given some example how to define a class. So here you can see here shopping cart is a class, and this class knows these card contents which are instance variables, and this class does these functionalities which are called methods. Similarly, here is the button class which has instance variables known as label and color, and it can do these functionalities. These are the methods like set color, set label, depress and undepress. Uh, let's move ahead. So guys, these instance variables, like you have to understand the terminologies here. The variables which we defined on the class level, these are the instance variables, and the functions under which we write our program which has to be executed, like these are called methods. Okay, these instance variables and methods are also called the state and behavior respectively. Okay, similarly you can some instance variable inside this television class, like its size, its color, its other specification like number of buttons, etc. And inside the methods we can put switch on the television, switch off the television, change the channel of the television, change the brightness of the television. Okay, so these are some examples to make it clearer. Now what is the difference between the class and object? So class is the blueprint of an object. Class is a blueprint for an object. It means class defines the type of the object we are creating. Let's read here. It tells the virtual machine how to make an object of that particular type. Each object made from that class can have its own values for the instance variables of that class. For example, you might use the button class to make dozens of different buttons, and each button might have its own color, size, shape, label, and so on. Look at this way. Look at it this way. Okay, here this example, I like this example very much. One analogy for the object is a packet of unused Rolodex cards. Okay, each card has the same blank fields, the instance variables. When you fill out a card, you are creating an instance of the object, and the entries you make on that card represents its state. The methods of the class are the things you do to a particular card. Get name, get change name, set name could all be the methods for Rolodex. So each card can do same things, but each card knows things unique to that particular card. So this is a very good example to understand the object of class and object. You can see each card has these instance variables name, phone and email, but these values are unique to these individual cards. So these individual cards here represent an object of this class. Okay, making your first object. So now we have to learn how do we make an object of a particular class. So here the dot operator is the key entity we use. The dot operator gives you access to an object state and behavior. So what do we do? Suppose we have a class called dog, and this class has instance variable size, breed and name, and these are the data types of these variables: int, string, int and string, and this is the method. Okay, so now if I want to access this variable and if I want to call this method, what I have to do is I first have to create an object of this class dog. So dog t is equals to new dog, then bracket and semicolon. This is how we make a new object. Then to call this method, we can simply call d.bark, and to access this size variable, we can simply write d.size equals to 40. Now see the example here. So now we have the class dog, and then we have another class inside which our public static void main method reside. Remember guys, we had discussed that whenever we execute a Java program, so the JVM starts looking for the main method of that particular class. So in order to create an object for the class dog, we are creating another class which is test class, and inside this test class we are putting our public static void main, and then we are creating an object of class dog, and we are just accessing its variables and calling the method. So this is how we create an object of a particular class in Java. Okay guys, then there are some more examples. You can go through it, and this will give you a better understanding of creating objects and accessing its variables and calling its methods. In the next video, we'll be coming with the next topic given in this book. And if anything in this video is not understandable by you, then please let me know in the comments, and let me know what type of videos you want to watch on my channel. And if you have any doubts, you can surely write down in the comments, and I will surely reply. If you like my video, please like, share, comment, and don't forget to subscribe to my channel. Thank you. Bye.